Okay, today we're going to be looking at intersections of lines and curves, mainly to do with lines and circles because the chapter's to do with circles. But we'll start off with a basic one to remind you from GCSE. I've got y equals x squared add 1, y equals 5x minus 3. Nice and straightforward in this case because the line is written as y equals, so wherever y appears on the other side I can replace it with 5x minus 3 in that case equals x squared plus 1. I get a quadratic, and I move everything across, so I've got two equations with two letters in, y and x, to one equation with one letter in, x. And when I move it all over there, I get x squared minus 5x and plus 3 and plus 1 is plus 4 equals 0. Hopefully, most of these are going to be ones that factorise. So I'm going to have x minus 4, x minus 1 equals 0, and x equals 4 and 1. Don't forget to stick that into either one of these to get the y values, so x equals 4, y equals 20 minus 3, which is 17, or x is 4, y equals 16, 1, 17, and x equals 1, y equals 5 minus 3, which is 2. And you can do them as points as well. Okay. Similarly for the circle and the line, what I need to do for the linear part of it is make one of them the subject, and since it's x plus y equals 9, there's nothing in favour of either making x the subject or y the subject. Because we tend to solve for x, I'm going to get rid of y. You've done loads and loads of solutions of x's. As I say, it makes no difference here whether I have an equation with a quadratic in y or a quadratic in x. So I'm going to take this one first and let y equal 9 minus x and stick that into that thing there. So I'm going to get my x minus 2 all squared plus now 9 minus x minus 3 becomes 6 minus x all squared equals 16. This is what you've got to remember when you're squaring things out. It's the first term squared there, last term squared plus 4, twice the product minus 4x there. It's exactly the same for this one, but I can treat this, because I'm squaring it, is instead of being 6 minus x all squared, I can think of it as being x minus 6 all squared. To get x squared, and then minus 12x plus 36 equals 16, and I can lump them all together. I've got 2x squared there, minus 4 minus 12 is minus 16x, and I've got plus 40 minus the 16 is going to be plus 24 equals 0. Divide by 2 to make it easier, x squared minus 8x plus 12 equals 0. Factorise it as minus 6 and minus 2 equals 0. So x equals 6, and stick that into the linear is probably best, y equals 3, and x equals 2, y equals 7. And I would check those in the circle as well. So 2, 7 gives me 0 plus 4 squared, which is 16, and this gives me 4 squared plus 0, which is also 16. So I'm happy with that as being the 2 points where the line crosses the circle. Talking of which, third example here, what can happen with lines and circles then? Either the line crosses the circle in two places, we get two solutions. The line could miss the circle altogether, which is what we're going to try and show here, or the line could be a tangent and touches. If you're told that a line is a tangent, when you get your quadratic equation in x or in y, it will be a perfect square. There will be one solution and one solution only. In this case here, I'm going to get a quadratic, and it doesn't meet because there's no solution, because b squared minus 4ac I'm expecting will be negative. That's where I'm going to go with it here. Now, because it's 2y plus x minus 6 is 0, if I make y the subject, I'm going to have fractions. And trust me, avoid fractions if you can. I'm going to make x the subject and call it 6 minus 2y. So I'm going to be using x equals 6 minus 2y and stick that into the bracket there where x appears. So x plus 4 becomes 10 minus 2y. So I get bracket 10 minus 2y all squared plus that y squared equals 16. So I've got a quadratic in y to solve, and as before, I can treat that as 2y minus 10 and squaring it. So I get 4y squared, twice the product is minus 40y, and then plus 100, and then plus that y squared equals 16. I've got 5y squared minus 40y, and then plus 84 equals 0. And if I consider the b squared minus 4ac, what am I getting there? B squared is 40 squared, 1600, and the minus 4 times 5 times 84 will give me an answer that's negative, because 20 times 84, 840 doubled up is 1680. That gives me minus 80, which is less than naught. Therefore, I have no solutions. So it's all to do with the value under the, when I try and substitute it in the quadratic formula, I can't get a solution because b squared minus 4ac is negative. Here's one then. Y equals 3x minus 1. I've got the equation of the circle, not with bracket, doesn't matter, and they've already done some tying out for me. It just means I've got two places to substitute for y. So I've got x squared plus 4x plus 3x minus 1 all squared minus 6 bracket 3x minus 1 plus 3 equals 0. So there's plenty going on here. And I'm going to work in columns because I like the columns. X squared plus 4x. Square out that, so I get plus 9x squared, twice the product, minus 6x plus 1. And then times by minus 6 to get minus 18x plus 6. And then I've got the plus 3 as well. So what have I got then? I've got 10x squared. I've got minus 24 plus 4 minus 20x and plus 10 equals 0, or x squared minus 2x plus 1 equals nothing. This is a perfect square. It's x minus 1 all squared equals 0. So x equals 1 repeated. It means the lines are tangent. There's only one solution. When x is 1, and I stick x is 1 back into the line to get y equals 2, 3 minus 1. This line then is a tangent. So if I was to draw the circle, draw the line, I've only got this one point of intersection because the line is touching, and that's it. So the three cases I can look at then with a line and a circle, either line intersects twice, example 2, the line misses because b squared minus 4ac is negative, or it touches because it's a tangent, and the expression, the quadratic I get, is a perfect square. Last example, is asking me to show where two circles intersect. This is normally going to be quite difficult to do. The only way I can do it in this case is because I've got the same function appearing for the x part here. So what I can do with this, I can say from this equation, rewrite it as x minus 2 all squared equals 36 minus y squared. And where x minus 2 all squared appears in the second equation, for the second circle, I can replace it with 36 minus y squared. So I've got 36 minus y squared plus y minus 10 all squared equals 64. Let's times it all out then. I've got my minus y squared plus 36, notice the gap. Times that out, plus y squared. Oh gosh, there we go. This is going to be quite interesting because they cancel out. I've got twice the product, minus 20y plus 100 and minus the 64 equals 0. So I'm going to get minus 20y, and then 136 minus 64 is going to be, I don't know, 132, 72. So plus 72 is 0. So y equals, and there's only one answer here, 72 over 20, 7.2, 3.6. And x then, I'm going to get two different x values, because when I stick in 3.6 into that, which is 36 and 7 is 18 over 5, when I put it into either one of these things here, let's put it into that one, that's the simpler one, it looks like there. I get x minus 2 all squared equals 36 minus 3.6 all squared. Oh gosh, just testing my so what's that? 3.6 times 10 minus 1 squared, 10 minus 3.6, really, sorry. Which is times 6.4, 36 times 6, because I haven't got my calculator, so I'm just faffing around like this, so I can square root it. Okay, so x minus 2 all squared is that, so x will equal 2 plus or minus this, x equals 2 plus or minus 6 times 8 over 10, 4.8. So x will equal 6.8 and y equals 3.6. X will equal minus 2.8 and y will equal 3.6. So I get two points there with the same y value but different x values. Okay, so they are crossing on the same horizontal line. So I've got a circle and a circle like that and like that. With the 2 points, I've got the same y value of 3.6. So it's going to do that sort of idea there. Okay, so that was a tricky little one, but it only worked because I've got the same function of x appearing that I could eliminate in that case there. And that hopefully gives you an idea how to sort out when a line and a curve intersect.